Okay, so let's get started. In this tutorial, we're going to be taking a look at understanding our injector data, learning how we convert an injector flow rate into an injector pulse width through our fuel modeling within our Motec M1 systems. Now, this is going to be more of a general overview of what goes on within the injector data programming so we can understand things better as we move forward in the next tutorial, looking at actually setting up and programming our manual calibration of injector data within the M1 system. And then we'll be also able to reference this a little bit better conceptually when we are programming and calibrating with the Motec, understanding if we have an error on the fuel modeling side or on the airflow modeling side when we're dialing in everything in terms of our fueling to our engine, utilizing something like our volumetric efficiency table. So let's jump in here and take a look at a couple concepts. So it's going to be getting everything started here, and this is going to be tying into, again, our next tutorial looking at programming the actual injector data. Now, what I want to do real quickly here is just move in to my calibration file that I have up on screen right now and jump up here into our workbooks and go into our setup area here. And we're going to be moving here into our, going into the injector data screen. That's going to be our third screen right here. This holds a lot of the programming information that we need to take a look at in order to calibrate and program our injector data. So I'll be just referencing a couple things on screen here as we're going through this training module. Okay, so the very first thing we need to understand is that we have this fuel and airflow model that we've talked about pretty extensively up to this point. We have fuel mass is equal to air mass divided by our target air fuel. Now we know our air mass is going to be derived, it's going to be an estimation of air mass. It's going to be derived knowing number of cylinders, engine displacement, the charge temperature, which is our density. It's going to also take a look at our map pressure and our volumetric efficiency percentage coming from our volumetric efficiency table. So all of that establishes our air mass, or the amount of air mass coming into our engine at any given time. Now we know what the target air fuel would be based on knowing our desired lambda coming from our target lambda table multiplied by our fuel stowage. So that gives us our target air fuel. If we know air mass, we know target air fuel, therefore we're going to know our fuel mass. So converting a fuel mass into an injector pulse width is going to be very specific in terms of knowing the injector flow rate. If we have a really small injector, it's going to take a relatively large injector pulse width to be able to open and close that injector to deliver the fuel that we're requesting, compared to a very large fuel injector. So something like a 2000 cc injector is going to have a very tiny injector pulse width, commanding the injector to open and close, compared to a small injector, it's going to have a very large injector pulse width. So when we're talking about the injector flow in terms of a programming value, that is going to correlate taking a fuel mass and converting it into a base injector pulse width. And what we're going to find here, if we look real quickly at our screen under the injector data information, we're going to find on something like our primary set of injectors, that's going to be, if we have dual sets of injectors, this would be the primary that always is running. This is going to be referencing in terms of the flow rate down here, reference flow and also reference pressure. Both of these are needed in order for the Motec to understand what type of injector it's trying to control, so the actual flow rate of the injector, and then what the base pressure is going to be. And that's important because as we vary the fuel pressure, the actual injector flow will vary, and then Motec can calculate that and figure that out really quickly. So knowing what a injector is rated at in terms of flow and at what pressure is important information to program. Now, how do we turn the reference flow into a base injector pulse width, or the baseline of where we want to actually open and close that injector? That's going to be taking us into a couple different graphical plots we're going to have coming up on screen here in this training module to better understand this conversion. So the very first plot I have coming up on screen, we're going to find on the left axis, that's going to be the injector reference flow, and the bottom axis is going to be our injector pulse width. Now looking at this, we have this line that's going within our X and Y axes here, and that's going to be representing the actual reference flow. Now in terms of injector language and programming, that's going to be known as our injector slope. What this is going to do is translate the reference flow pressure into an injector pulse width when we're requesting a certain amount of fuel mass at any given time. So again, we know our air mass, we know our target air.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.